So this is the day 31 of our Leetcode daily until I get a job. So there was previous 2 days I didn't make a video, but I did my questions to maintain the streak. But I couldn't do the videos as there was a tragedy in my family, as my grandfather expired. So that was the reason. But anyways, let's continue with today's questions. And I have like put out 4 questions which we are gonna solve, and these 4 questions are the basically the I'm doing the consecutive questions. So these are the 4 questions: Sudoku solver, count and say, combination sum, and combination sum 2. Okay, so first question is Sudoku solver. So we earlier did the valid Sudoku question where we were checking that if the Sudoku is valid or not. So we will be needing that question's logic here also. So here what we did was we just checked if a Sudoku is valid or not, and we checked with this uh, basically function that in which we pass the board, and the row and the column means the coordinates of the number we are checking and the value of it. If it is valid, it will return true, otherwise it will return false. Okay, so we'll be needing this function in this question. So what we basically do in this function is, in this question is, there are dots. Okay, in place of dots we have to put number, and we have to put the valid number. So what's the condition for a Sudoku is that whatever number we put at any place, like if we put a number at this place, this number should not be repeated in this row or in its column or in the box it is present. Like there are 9 boxes, small boxes, this one 3 by 3, 9 boxes are there, and that number should not be there in its box. Okay, so these are the 3 conditions it should satisfy. So we will go and try every number to we'll go and try to put every number here, whichever seems valid to us we will put it here, and then we will go to the next value. Okay, and we will basically backtrack here. We will try to put one, uh, if it is valid, no, not backtrack actually, but if it's valid then fine. Otherwise we will go to the next value and check again. Okay, and if it's not valid, we will again like put the dot in place of it, right? Like after putting this let's say x is the value, after putting the x value here, and we try to solve the rest of the board. If the rest of the board is fine, then we are good. But after putting the value x here, the rest of the board is not fine, it is not good. Or basically not good means it becomes an invalid board somewhere in future. So we will backtrack and put dot again, and we will try to give it another value. So we will do this process. This seems a bit like difficult to explain, but it's really easy and straightforward in code to solve, and you guys will get it once we solve it. So we will just call a function here which is this. Okay, and this will be a boolean function which will basically change the board itself. Okay, and that board we have to change in place. We are not taking a new board here, it's a void return function, so we have to change the board in place. So it will just take the same board, and after that we will see, we will go to, we will try to run the for loop for all matrix or all the Sudoku. So we will go to each of the row. There are 9 rows and there are 9 columns, and what we will do is, if the board value is a dot, if it's not a dot value then it's already solved, so we don't care about that. We just have to fill the dot values. Okay, if it's a dot then it's a matter of concern for us. So we will do what is, we will try to put all the values, means we will try to put character and k from 1 to k less or equal to 9. 1 to 9 we will try to put each value into it, and whichever value this function we will pass here. We have to check valid after this, right? So check is the function. So if check for the board, and here I, j and k will be passed. I and j are the coordinates of it, k is the value we are passing. If this value is satisfied at this I and j in this board, then we are good. We will change the value of the board to k. And now if further going, if this solve for this board is good, we will just return true. Fine, it will return true. And else if not, we will again put the board ij, which we put earlier value, or the k, we will again put it as dot. Fine, so this will do the thing. And otherwise here after the if maybe after the for, inside the if this doesn't return a true, obviously we have to return something else, so it will return a false here, that this sudoku cannot be solved. Okay, and if all the things comes good and we reach to the last, then it's a return true, because otherwise it will return a false right there. It won't go to the end. If it goes to the end, then every value is solved and we're good with it. So we just copy this check function, because that will be the same to check this condition remains the same. So we will just copy it, and if we paste it here, and yeah, perfect. Yes, so if we run it, fine, working fine. So if we submit this, yeah, so we can see that that's a pretty easy question, and like there's not much of a complexity in this. We just have to go with the flow, go with the process. What's normally the process for a sudoku? That's it. Now the count and say thing. The count and say sequence is a sequence of digit strings defined by recursive formula. Count and say for 1 is 1. Count and say for n is the run length encoding of count say n minus 1. So if 5 is there, then it will goes to 4. 4 goes to 3, 3 goes to 2, 2 goes to 1. So for 1 it is 1. For 2 it will be like for 2 it will be encoding of the previous one, which is this, so it will be 1 1. And so basically it gives us that RL is a string compression method that works by replacing the consecutive identical character with the concatenation of the character and the number of marking the count of the character. Okay, so if 1 is 1 time, so it will be called 1 1. But now this 1 1 will be for the count and say for 3, and it will be 2 1, like 2 times 1 is coming, so 2 ones. And 2 1 will call 1 time 2 is coming, 1 time 1 is coming, so 1 2 and 1 1. And for this what we call 1 1 1 2 and 2 1 for count and say 5. Okay, so this is how it's gonna work. But in this question, how we can do this is, okay, yeah, so in this question how can we do this is simple. Wait a second. Yeah, fine. Okay, so what we can do here is, we are given with a value n. Okay, we can call a recursive function for n minus 1. We will calculate the things for n. We will store it in a string, and we will call a recursive function for n minus 1. And we will go to n minus 1, n minus 1 to the last, right, up to when it's 0, because when n is equal to 1 it will be 1 only, but when n is equal to 0 it will return. Okay, so it will return at that time. So what we can do here is so our base case is what? Base case answer is basically this, and we what's the constraint? N won't be 0 and will be minimum 1, so we can take as this as the base, and we will return solve function which will be called for n minus 1, and answer will be passed on here. What this will return is string solve. It will be integer n minus 1, integer n obviously, and string answer. Okay, we'll concatenate the current value like answer for current case in answer, and we'll go forward with n minus 1 again. That one's nice. Okay, so if n becomes 0 after all the decrementing things, we will just return answer. Okay, we don't have to do anything in this case. Otherwise, see what we can do for one string is, let's just say we have 1 2 2 1 1. We have this. Okay, what we can do here is, let's say this is I and this is j. We will increment I up to the point wherever answer I is equal to answer j. Answer I is equal to answer j, I plus plus. Answer I is equal to answer j. No, they are not. So I is here now. I is here now. J is here. What's the length of ones? So it should be 1 1, right? So what it will be, j minus I, sorry, I minus j, that is 1 minus 0, index is obviously 1 minus 0 1, and times of 1 plus, we will concatenate what string? This nums j, that is 1. So 1 1 comes here. So now, and j will be now equal to become to whatever I is. Now here, from here again I will start I equal plus plus equal plus plus, I will become here. Okay, their difference is 2. So 2 times of what is nums j, sorry, string j, again 2. So 1 1, 2 times of 2, and 2 times of 1. This will be the string of it, right? This will be now again 1 times of 1, 3 times of 2, and 1 times of 1. No, this will become actually 2 times of 1. 2 times of 1. So now no two consecutive strings are same, are they? No. So this is the final answer of it. It should work in such a way. Okay, so what we can take is two variables I j, initially both 0, and we will take a temp string for the current answer. Okay, and we will iterate through this answer string, whatever we are getting. Okay, so while I is less than answer dot size, and again while loop, answer I equals to answer j, and I is less than answer dot size. If this is the case, we will just do I plus plus. Now whenever this condition becomes false, answer I is not equal to answer j, then temp plus is equal to what? Temp plus is equal to will become I minus j, and to be string, we will just add this character here. Okay, this is the length, and now the character itself plus is equal to answer j, right? And now j will become equal to I. Done. We will just call this now we will call the function again. We will return, and it will return the function again with n minus 1 and temp be the string here. So in this way it can be done, I think. Yeah, it's working fine. Perfect. It will start from 1 and go up to 4. For 1, it will return this. Obviously, we have initially put it as 1. For 2, it will be RLE of this. This is 1, 1. For 3, it will be RLE of this. This will be 2, 1. And for 4, it will be RLE of this. Means 1, 2 and 1, 1. This is our answer for this case. 1, 2 and 1, 1. RLE is basically run length encoding, which is a string compression method and which is here explained in this question itself. So this is the case with it. Now the next question, combination sum. See, combination sum has a lot of parts and it has two methods to do it. As clear from this, obviously a backtracking is the main solution here. Further parts can be done with dynamic programming also. So with this part, we are given a number of distinct integer candidates and a target integer target. Okay, there is an array given and there is a target given. Return a list of unique combination of candidates with a chosen number sum to target. Okay, हमें छोटे छोटे arrays बनाने हैं जिनके elements का sum target के बराबर होगा, and these elements should be picked from the candidate itself. It means the combination should be picked from the candidate itself. Now the condition is that the same number may be chosen from the candidates an unlimited number of time. हम कितनी ही बार यूज कर सकते हैं 2 को, कितनी ही बार 3 को, कोई प्रॉब्लम नहीं है. ठीक है, there is no problem with that. But the combinations must be unique. They can never be the same. Means no two combination must be same. Means they should not contain same element same number of times. Okay. So like 2 to 3 is there. There should not be another combination in the answer which will contain 2 2s and 1 3. Okay, in any order. So simple, basically we can just directly go with the backtracking solution. What the backtracking solution will look like is that firstly, as there might be repetition in it, so to handle the cases and to avoid duplication, we will just sort it out. Okay, because what will be the benefit of the sorted array is that it will help us eliminate the duplicates, because duplicates will be staying together and we will it can help us to discard out the duplicates. So what we can do is that let's sort firstly. Candidates is a big name, so let's take it as C. So we'll sort it from C dot begin to C dot end. Okay, it's sorted now. We will take our answer vector of vector int answer. We will take the small vectors as temp and we will just solve the function. We'll call the function that solve, which will get candidates, what's our target, the answer array, the temp array, and the index. Currently we will start from the 0th index and we will just return the answer. Now it will be a void solve. So vector of vector only, vector and C int target, fine, and vector of vector int and answer, vector int and temp. What's remaining? An int index means I, which is initially 0. So we will go forward and we'll check if the I becomes, or if the target, our main thing is target. If the target becomes 0, because we will, whatever number we will include in our answer, we will decrement that number from the target. That this much target is achieved, this is remaining. Okay, we'll send the remaining into the next function call. If target is 0, we have achieved it. So we will just answer dot push back temp uh, temp, and we will return. Now you may ask that why are we not doing the temp empty again once we got answer, because we will do backtracking here. Okay, you will understand how we are doing this. So while I is less than c dot size, whatever index we are getting, if that index should be less than c dot size firstly, and the value at that index must be less or equal to target. If that value is greater than target, then there is no point in checking that. Correct? So that value in the candidates at that ith index should be less or equal to the target, then only it's of our use. Fine. And then if it is, then we will just push back that value in our answer, means temp. Okay, we will push back it, and we will call the function again, and this same number can be used infinite number of times, unlimited number of times. So that's why we will do one thing. We will call this function again and go with the same index again, like we first called it with 2, then again we will call it with 2, because there is another second 2 in here. Like if the like in this case, if the target is 8, it can be achieved either 3 3 2, or we can take 2 4 times, 2 2 2 2. Okay, so we have to call for the same index. If it's fine, then good. If it's not, then it will return us, obviously it will backtrack with the original value, and then we will increase the index, and then we will back. This is the step where we are backtracking. Whatever we entered in the last position, we will just backtrack it. But there are a lot of function calls in between them, and they will be working in a stack manner. Like the last function call will be executed first. Correct? So this is how it can be done. And if we remove this, so let's see if this is working fine. Okay, stack overflows somewhere. So it is vector and c in target, vector and vector 1, so vector in temp. Again, target 0, vector I dot 0 size, ci is less than target. If ci is less than target, then we'll consider ci. We will add ci to the answer, and we'll solve it again for target. Okay, we have to decrement this value also, right? If we add this in our answer array, then we can decrement this value from the target, and then rest of the target we need to solve it. So yeah, this is working fine now. Okay, fine, we got this. So now let's go to the next question, which is again combination sum 2. Now this combination sum 2, given a collection of candidate numbers and a largest number target and target number target, find all the unique combination in candidates where the candidate numbers sum to target. Means and each number from the candidate may be only used once in the combination. So एक combination में सिर्फ यही numbers use हो सकते हैं, ठीक है, इनके अलावा कोई नहीं हो सकता, और एक नंबर उतनी ही बार यूज होगा जितनी बार वो कैंडिडेट्स एरे के अंदर है, नॉट अनलिमिटेड टाइम्स. ओके, सो पिछले क्वेश्चन का मॉडिफिकेशन है. पिछले क्वेश्चन में हम सेम इंडेक्स के लिए कॉल कर दे रहे थे, क्योंकि उसी इंडेक्स को हम वापस ला सकते हैं आंसर में, लेकिन अब नहीं ला सकते. तो ऑलमोस्ट वही सेम ही आंसर होगा, बस थोड़ा सा डिफरेंस हो जाएगा कि हम वी आर नॉट कॉलिंग फॉर दैट सेम इंडेक्स. एंड ऑल्सो वन मोर थिंग दैट yeah, that's the only thing. So what we can do here is again like the previous question, we will sort it out and we will call the function just like this, the same way, no difference. Yeah, and now we will call the solve function as void solve, and let's just put the same things here. This will be done C here. Okay, now for this thing, what we will be doing is, if target is 0, we will do this answer dot push back temp, and we will return. Fine. and otherwise we will go to all the index starting from I. Okay, I is less than c dot size I plus plus, or not I plus I is less than c dot size, and target must be less or equal to ci must be less or equal to target. Okay, if this is the case, then we will go, and yeah, if next number is same, see what if the next number is same as the previous number? We can add it, right? I don't think there should be a problem with that case. So if this is the thing, we will just put it in our answer. Ci, we will call the function again with the c in here, target in here, answer in here, temp in here, and I plus 1th index here. Okay, I plus 1th index here, and we will do I plus plus, and we will do temp dot pop back. Let's see if this works fine. I think it should. Okay, it's giving a output of this. Yeah, target minus ci, obviously. 116, 125, 17, and 26 there, but 125 is coming again and 17 is coming again. So numbers are being repeated here. Okay, 125, 17. So 1 2 comes, then 5 comes, then 5, then 7 again, retraces to 1 again, then 1 7 comes here. If 1 7, okay, I guess yeah, we need to if the number is previous number is same as that is, then okay, if I is greater than 0 and ci is equal to ci minus 1, then we'll just continue. But the I plus plus has not yet happened here, so it will not give any different result, correct? It will just keep on, yeah, memory limit will be exceeded obviously. So it should be this, that I is incremented and then we continue. It's also giving wrong again. 1125, 117. Ci minus 1, then we'll just continue. Why don't we run a for loop in this case? What if we done a for loop and we will take index I is equal to index j equals to I to j is less than c dot size and j plus plus. One condition we have to put it on top here is again this one. Okay, wait for 1 second. Let me try this thing. Maybe it could still work. Obviously we continue this, but why we are pushing back the value, it should be here. Okay, okay, it's still giving the wrong answer, that 116 is not there. 26 is there, 17 is there, and 125 is there, but 116 is not there. What's the reason for this is we are going to the next value. It should work fine, but yeah, let's again go with the for loop, that try it with like this, that if int j is equal to I to j is less than c dot size and j plus plus. What we will do here is, if I is greater sorry, if j is greater than I and cj is greater sorry, is equal to cj minus 1, then it will be j plus plus. It will be j plus plus. No, it won't be j plus plus actually. We won't do anything because j is already incrementing here. Then we will push back the c. Okay, we will only push back if the target is greater or equal to the cj. Okay, and if it's not, like if cj is greater, then we will break right there. Okay, otherwise we will push back cj, we'll do this, and we will go with j plus 1, correct, and we can remove this, and again it will pop back. Let's see. Yeah, this works fine. I will try to find what was the issue with that method with the while loop. There might be a small issue in that which I'm not noticing right now, but I will try to do it later. But yeah, these were the 4 questions we tried to do, and we done them all. And was there any hard? Yeah, Sudoku solo was hard, but we did it under 7 minutes, I guess, and that was a pretty good thing for us. So what's remaining on that page is first missing positive, wildcard matching both hards, and then permutations 1, permutations 2, rotate image easy 1, power of x and n, power x n. So these are pretty standard questions remaining. This question is really good. This is fine. Permutation 2, easy ones. Rotate image very easy. Like I remember this question orally only, that there's a matrix given, we'll first transpose it, that and we are making a transpose of it. So हम कैसे करेंगे उसको? We'll first take its transpose to rotate the image of it to 90 degree. We'll first take its transpose and then swap the columns in order, like first column swap with last, second number with second last, third with third last, and if there is a middle it will remain as it is. If it's not, then all others will be swapped with their uh, corresponding parts. So that's the question. So yeah, we will do this in the next video. So this is the day 31 and we are done with it. So we did all of them in under 34 minutes, and that's pretty nice. So that's all for today.